let's look into today's problem of the lead code, single number, problem number 126. Okay, given a non-empty array of integer nums, every element appears twice except for one. Okay, find that single one. If you look into the example, let's say we have an example 4, 1, 2, 1, 2. So here 1 is repeated twice and 2 is repeated twice, and 4 is the only element which isn't repeated, like which is a single element. So we have to return that particular element throughout the array, right? If you look, we have an array 4, 1, 2, 1, 2. Element 4 is single element and the rest of the element are repeated. Okay, so we have to return this single element. If you look into this, we have to, for this, like to solve this problem, we have two solutions. The first one is the brute force solution, and the second solution is the optimal solution. I'll just walk you through the brute force solution first. If you look in the brute force solution, we'll be taking an extra space called an hash map. Okay, why we are taking hash map? Hash map contains key value pair. Key value pair. Here in the key, we'll be storing the element, and here occurrence of the element. Right. For example, if we traverse through the array, the first element is 4, and its first by default occurrence will be 1. Then we'll be traversing 1, and its occurrence will be 1. Then again 2, 2's occurrence will be 1. Then again we got 1. So we'll be updating this, like for the element 1, we'll be updating value, so it will be 2. Similarly for 2, it will be 2. So the final hash map will be 1, 2, 2. If you look into this, this is our hash map. Okay. Then we'll get the hm dot get value of the minimum element, right? So it will return the element 4 here. If you look into the optimization, like if you look into the complexity of this one, this space, like this hash map, takes extra space, big of n, and traversing, which takes time complexity, big of n. So total base complexity is big of n, and time complexity is big of n. So we have an optimal solution as well for this one. Let's say I have an example 4, 1, 2, 1, 2. For the optimization solution, I'll be having space complexity as big of 1. I'll not take extra space, and time complexity for traversing will be big of n. Using XOR. XOR. Right. I'll tell you the logic. Let's say initial variable is declared with 0. So this is the resultant variable 0. Then I'll be traversing throughout the array. So 0 XOR 4 will be 4. Okay. Before going into this one, I'll just let you know XOR, how it operates XOR. If same element A XOR A is there, it will cancel out and it will give you the 0. And similarly, A XOR 0 will be resulting in A. I just remember this one. And 0 XOR 4 will be 4. So resultant will be 4. Similarly, the next element 4 XOR 1 will be 5. I'll tell you how it is 5. Like 2 power 0, 2 power 1, 2 power 2, 2 power 3. So 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8. Okay. Now let's say I have 4, 0, 1, 0, 0. This is 4. Then next element is 1, 0, 0, 0, 0. If you see, A XOR 0 is A, 0 XOR 1 is 1, 0, 0 is 0, 1 and 0 is 1, 0, 0 is 0. So if you calculate, this is 4 and this is 1, it will result in you 5. So the result right now is 5. The next element is 2. 5 XOR 2. 5 XOR 2. Again, this one will be 2. This one will be 0, 0, 1, 0. If you calculate this one, 1 XOR 0 is 1. 0 XOR 1 is 1. 1 XOR 1 is 1. If you calculate this one, 4 plus 2 is 6. 6 plus 1 is 7. So it will result you as 7. The next one is 7 XOR 1. 7 XOR 1 will be resulting you as 6. For example, 7 was 0, 1, 1, 1. This is 7. And 1 will be 0, 0, 0, 1. 1 XOR 1 will be 0. 1 and 0 will be 0, 1, 1 and 0 will be 1, 0 and 0. So this will be resulting as 6. So right now I have result as 6. Now the last element is 2. 6 XOR 2. So this is 6 and this is 2. 0, 0, 1, 0. 0 and 0 is 0, 1 and 1 is 0, 1 and 0 is 1, 0 and 0 is 0. If you look, this is 2 power 0, this is 2 power 1, 2 power 2, and 2 power 3. So 2 power 2 is what? 4. So the result array is 4. So this is the unique element, which is single element. Now let me, this will be result is equal to 0, and I'll just iterate for num in array result XOR with the num, and finally return the result. So this is the basic logic, and with the optimized solution. We are not taking extra space. This is only for time complexity will be big of one. That's all. Result is equal to 0, and for none in none, result XOR is equals to none, return result. So all the test cases have been passed. Runtime is 32.7 ms and memory is optimized. Thanks, guys.